This is a coverage of Chapter 3 in the first Cisco course. Chapter 3 covers a lot of material in it. I've got some videos for you in Angel in a separate category sitting there in the chapter labeled Video Lectures. I cover the TCP/IP model and the OSI model in those video lectures. As you look at them, you'll know some of those have been recorded a while back. As you look at different ways that I have looked over time, but I would definitely encourage you to go over those. There is a lot of material in this chapter, and I want to go over some of it real quickly for you, just to give you an overview and hopefully make it a little bit more some sense to you. The first thing they talk about is that they talk about protocols in the chapter. And protocols are just rules that we use to communicate with on the network or internet. You follow protocols in real life also. Protocols are just ways that we normally work, but they're not laws, but they're generally agreed on ways to do things. For instance, it's protocol to walk down in the U.S. on the right side of the hallway. It's protocol for an American citizen when they meet the Queen of England to just shake her hand. If you were a British subject, protocol says that you should bow or curtsy, depending on if you're a man or a woman. That's protocol. Protocol says that a diplomat appointed to a country, first thing they do when they get to that country is go to the ruler in that country, or whoever the head person is in charge in that country. In the U.S., if they come to the U.S., they go to the president and present their papers and show that they are representing that other country. So there's all kinds of protocols out there in the world. There's other protocols that affect us also that we follow by. And then there's laws out there that we follow also. The law says we drive on the right side of the road. Protocol says you should walk down the right side of the hallway, but you don't have to, although it makes it a little bit more efficient and works better if we do tend to follow the protocol on that. Well, the protocols are the rules of how communications occurs across the network. And there's different sets of rules for that, and each one's a different protocol. So there's hundreds and hundreds of protocols out there. A lot of them are grouped into suites or groups of protocols, and the big one that you'll see out there is TCP/IP. TCP for Transmission Control Protocol, IP for Internet Protocol. And that's actually the name of two protocols that are in that suite, but there's actually a bunch of protocols in there. We'll be covering some of them in this course, some more of them in later courses, but the big part is to realize that these are rules and that they give rules of how, when you go to send something from one computer to another computer, that it successfully sends it from one to the other. Now, as the average user, the user doesn't realize what all is involved in the protocols going on behind the scene. But it's the way that the information is carried. It's just like when you talk into the telephone. You know it gets changed into an electronic signal and sent across the telephone wires and changed back at the other end. But exactly how it does that, you've not ever known. Now, you're learning in this class about when you hit enter, what happens with that information that it gets sent across, to get it sent across the internet and get to the other machine, and if you were asking for information, for that information to be sent back to you. But that's what protocols are going to be getting into. They talk about encoding of them, and that's just where it's transformed from one format into another format. At the very beginning, from the format that you typed it in into a machine format, and then into different protocols as it travels along the way. There are limitations on the sizes of the messages as they go along the way. We're going to talk about encapsulating messages, where we're going to put messages inside that we're going to put other information around a message we already have there with information, and that we're going to be putting it inside of things. Encapsulating says we're taking what we've got right there and then putting other information around it. Think of encapsulation just like pills that you get out there. If you get capsule pills, what is it? It's got a nice little wrapper around it that holds all the little tiny pills inside. And so those little tiny pills inside that outer wrapping, which actually is made of bone, of animal bone, to make that outer wrapping piece on it that you thought might have been type plastic, but it's not. It's actually a product off of bone. is that you've encapsulated those little pieces of medicine, and you're going to encapsulate messages also. So you've got lots of protocols that govern the communications, and they're going to talk about these, and we're going to be talking about how they all come to play. And that's what we're going to spend most of the book talking about from here on. Protocol suites. The big one out there for you is the TCP/IP one. And then there are some protocols out there that are also, and those are open ones. There's also some out there that are proprietary protocols. Proprietary protocols are protocols that were developed by a company or an individual and applied just to that organization, or the person that created it still owns them, or that organization still owns them, and they control it, and that it's not available for everybody. And quite often you have to pay for the use of those. Some start out as a proprietary protocol and then become an open protocol. Ethernet was originally a proprietary one, and it was developed by Bob Metcalfe, who was a pioneer in computers and actually still doing things out there, and you can find articles by him today. He used to write a lot of articles about computers and kept it usually interesting on it. I always enjoyed reading them in Info World when he would write those articles on it. TCP/IP has come a long way. It actually was developed with the original development of the Internet, because it was the protocols developed for the Internet. It is a Unix-based protocol suite, so it dates back to 1969 and has been continuously updated since, and that you're learning about the latest version of TCP/IP with IP version 6. That's been around since 2000, but it's just now really getting fully implemented out there in the world. So we've gone through a lot of those. They list for you in the book on pages 130 through 132 a number of different protocols, and we're going to talk about those as we go on through the book. As we look at different layers, different protocols work on different layers, which leads us to also about who sets the standards for these protocols. And there's a number of organizations involved in that set these rules out there. That they mention several in the book to you. The ISO, IAB, and IETF, you'll see them responsible for some, but you don't see them mentioned a whole lot out there of developing them. But they do develop some of your protocols out there for you to be using. IEEE is one that does a lot of your protocols out there, and theirs are usually easy. For instance, all of your networking standards as far as how the wiring is actually done, and a lot of other things on wiring and physical things are done by IEEE. And for instance, you have seen some of those and you just didn't realize it. 802.11, you've seen that number out there referenced on wireless, because 802.11 is IEEE's standard for wireless networking. And then they've developed the letters that you've seen about B and G and N and such, and now with the AC and AD, that those come off of, that's the actual standards that was developed by IEEE that says this is what it has to meet to be wireless, and for different organizations to use the same standard. And so you can use a Netgear wireless box with a cist wireless box, and they work together, and that because they're both working off the same standard. If they weren't using the same standard, which is the way it was back in the 80s, then you could only use Netgear equipment with Netgear equipment, and cist equipment with cist, and so on. And cist, remember, is the consumer product side of Cisco. ISO, we're going to talk a good bit about it in just a moment, but that's another standardization organization. That's the International Organization of Standardization. Yes, I just did tell you, International Organization of Standardization, and that it's ISO is the acronym. There's a reason. They don't use iOS for it, because that is a chemical symbol out there, and they chose not to go with that chemical symbol on it. They went with ISO. If you're taking gone to Dreamspark and pulled down some of the different files from there. You notice they were .iso files. That ISO is the same thing there. They set the standard about how to take a CD image and put it into a single file on your computer. ISO is the International Standardization Organization, or the International Organization for Standardization, but it's the international group that does standardization. They set all kinds of other standards also for the world. There's also a group in the United States that sets standards just for the United States, which is called ANSI, and you'll see that one mentioned sometimes, ANSI, American National Standards Institute, which is located in Gaithersburg, Maryland. For instance, they define exactly what an ounce of gold is. They define what is an ounce, what is a pound, and other things. There are other standardization organizations that you'll see, and that we'll mention some of them later on. EIA-TIA actually sets on how wire is for some of our wiring. So you're going to see that come up in terms of what type of wire and whether it meets a certain standard or not later on when we talk about Category 1, Category 5, particularly Category 5, Category 6 wire, or Cat 5 or Cat 6. The reference models is a model, and there's two of these that we're going to use. And that's a model of here's how information gets put out onto the internet and how, or onto a network specifically, and how it's received, and how both ends effectively communicate with each other, and that the information goes through a number of layers. OSI, and these both date back to about 1980 when they were developed. The OSI model is a 7-layer model, and I've got the video describing it in more detail for you in the Angel materials. But it's a 7-layer model, and from bottom up, it's the physical layer, the data link layer, the networking layer, the transport layer, the session layer, the presentation layer, and the application layer. And you see them referenced sometimes from the bottom up and sometimes from the top down. The top one is layer 7, the bottom one is layer 1. When you get down to layer, you start with the information going in at layer 7, and that it then is processed on your computer down till it's put on the wire or whatever media, the air or fiber, on layer 1, and the wire or whatever media we're using is layer 1, and then it's received at that layer on the other end, and then it moves up the layers and gets it back to where it's presented in a format that the program and can understand up at the very top. And the layers effectively talk with each other between them. To remember those layers, the way I've learned to remember the layers on OSI is from the bottom up, using the mnemonic of programmers: do not throw sausage pizza away. And if you've ever known some real pure programmers that weren't, sometimes a lot of them aren't social people, they're technical people, and tell them what it is you want done and put them, and they go hide away in their little cubicle or their little office and sit there and work and may work for days, and quite often they like pizza slid into them, and that at some point you send in the hazmat team to go clean their office out. So that one is an important one for you to learn the layers. And then the TCP/IP model actually is doing the same type thing, developed about the same time by a different group, and it's a 4-layer model. And it's only got 4 layers, and it's from the bottom up. The bottom one is the network layer, the next one is the internet layer, the transport layer, and the application layer. The transport layer in both models are exactly at the same spot and do the same thing. The confusing part is on this one, the network layer on the TCP/IP model corresponds to the physical and data link layers in the OSI model. And then the application layer in the TCP/IP model corresponds to the top 3 layers of the OSI model, which is the application, presentation, and session layers. The TCP/IP model mnemonic that I have learned for that one, that my Cisco instructor taught me when I was taking Cisco, was: a teacher is nuts. and that's going from the top down in that case, just as an acronym. When you go to take the test, I would recommend the very first thing you do, have a piece of blank paper there for you, and when you go to start the test, write down for yourself all 4 layers of TCP/IP and all 7 layers of OSI, at least the first letters, so that as you go through the test, you'll be able to remember which is layer 4, which is layer 3, because you're liable to get those confused. That I've had that problem. They talk about encapsulation later on. The packet data units, we're going to talk about different protocol data units, or PDUs, as we go through. We're going to talk about segments, packets, and frames as we go in later chapters, and then bits when you get down to the very bottom, and it's data at the very top that we're going to be looking at those specifically in later chapters. But segmentation just says you're sending a message, and it's this big of a message, but your network can only handle messages that are this long. Segmentation says we break your big message into little ones so that you've got a whole group of little ones. Picture it just like when you go to mail a package. The post office says you can only mail, or UPS or FedEx says you can only send a package of a certain size. So what do you do if you need to send something that's bigger than that size? Well, the thing we normally do is we take it apart and we send in one package part of it, and another package part of it, and another package part of it. So you have segmented your package, and then you send it and you label each package what it is. Then at the other end, who you're sending it to gets all the packages, and they put them back together, open them all up, look at what you've numbered them, put them together, and they've got the same unit that you went to send them in the first place. And so you segmented them, and then they unsegmented them at the other end, putting them all back together. And as we look at the OSI model and the TCP/IP model, we're going to also illustrate those related to the post office. For instance, when you mail a letter from here in the east to somebody out west, we write our letter, stick it in an envelope, and address that envelope. That's going to be putting an addressing on it. And then as it starts through the postal service, you go and drop it in a mailbox. And then they're going to put it in a bin of which post office does it go to next along the way. And then they keep changing on that. So it actually gets re-encapsulated as it goes along the way into larger packages, although they're quite often just bins along the way. But it keeps getting that till it gets to the other end. And then the person on the other end will proceed to open it up. Actually, they'll look at the addressing, see what the physical address we sent it to, and then see if it's the right person or hand it off to the right person in the house. And then they open it up, and they got the letter just like you put it in the envelope in the first place. But that letter has been enclosed into other different packaging all along the way. So don't think about this whole process as being something totally odd. The addresses, we're going to talk about physical addresses and logical addresses. The logical address is going to be the address that is what the machine is known by, and that's going to be the IP address on it. That's going to be similar to on that letter that you're mailing, that's the name of the person you're sending it to. The physical address will be like where you've got the street address and city and state on the letter. In this case, that it's where you've got the physical address of the machine. And your machines actually have a physical address, which is called a MAC address. And those addresses are in hexadecimal, and that they're lengthy ones on it in groups of 4 characters. And then you've got an IP address on them, which in IP version 4 was addresses that had numbers that looked something like 192.168.3.1. Each of those numbers could vary from 0 to 255. Or in IP version 6, they're in hexadecimal, and that they're in groups of 2, and that there are 8 groups of numbers on there of 2 hexadecimal numbers in each one. And so we'll look at those more as we go along the way, but they mentioned to you about MAC addresses and IP addresses here also. That there is a quick summary for you of Chapter 3, and if you have problems or you're not understanding on it, do send me notes, post things on the discussion board, and make sure you do watch and view the different lectures that I have out there that mostly are videos, and so I'm illustrating it to you on the board where those were recorded of me actually presenting the information in a class.